So I'm working on the genetic risk factors that predispose to childhood diabetes. So we want to know in those genes that cause a high risk of developing disease, we want to try and figure out exactly what are they doing to the body. So we're looking at which cells of the body they're actually working on. And then when we design therapies to try and correct those genetic defects, we'll know exactly the right place to target the therapy so that it has the best chance of curing disease without side effects. I've discovered that one of the genes that predisposes to type 1 diabetes doesn't work only in the cell that we thought it did. It actually is working in another cell that is involved in activating the immune system. So this is really an interesting area that we might be able to target for future therapeutic use. What I'm working on in the future, we're just setting up a study in children that have type 1 diabetes and their brothers and sisters, and we want to screen the brothers and sisters and compare those to the diabetic children and the healthy controls, and we want to try and see if there are any biomarkers that we can identify that would predict their risk of developing disease in the future. What we're really hoping to be able to do is identify people before they get diabetes. So if we can find a way to screen them, to find a biomarker that would predict who is going to get disease in the future, then we would know who we have to target with immune therapies. Immune therapies are going to be expensive, and we don't want to just be doing them, randomly to people in the population. We want to know who is the person and when is the right time to try and intervene and come in with our new therapeutic interventions.